This is Vadan Shashwat. I am going to explain you sample paper question of subject mathematics class 9. Let's jump on to the first question we have. We have in here an exterior angle and adjacent angle of a triangle are in ratio 5:4 and one of the interior opposite angle is 30 degree. So we have to find the other two angles of triangle. So I have taken the exterior angle as x, the adjacent interior angle as y, and one of the angle that is given here is this 30 and the other angle which we have to find is w. So now by using the property of exterior angle property we have y plus 30, that is y plus 30 equals to the exterior angle x. Now the ratio is given between exterior angle and adjacent interior angle. We have x by y equals to 5/4, and using the triangle sum property, that is the sum of angles of triangle is always 180 degree. We have 30 plus y plus w equals to 180 degree. Now, using the equation 2, we can write x in terms of y and replacing the same in equation 1. So we will have y plus 30. Now replacing the x in terms of y, we will have 5/4y, which will lead us to y equals to 120 degree. We have got the one of the two angles of triangle which we needed to find. Now using y equals to 120 degree and putting this value in equation 3, we would get the value of w as 30 degree. So we have found the two angles of triangle, that is 120 and 30 degree respectively. Let's jump on to the next question we have. We have in here, we have the value of x if 25 to the power x minus 3 into 2x minus 3 equals to 3125. So we have LHS equals to RHS and we have to find the value of x. So for finding the value of x, what we can do, we can make the bases equal so that we can, if bases are equal and LHS equals to RHS, so power will also be equal, which will help us to find the value of x using this equation. So we can write 25 as 5 square, which will be which will give us which will help us to write this as 5 square 2x minus 3 2x minus 3 and 3125 is equal to 5 to the power 5. Now since base are equal and LHS equals to RHS, this will be equal to this. Here it is, this equation. And now simplifying this equation, we would get 4x square minus 18x plus 13 equals to 0. So in this equation we can conclude that we have a equals to 4, b equals to minus 18, c equals to 13. Now using this a, b, c, we can obtain the value of x as minus b plus minus under root d by 2a. We'll get two values of x and we know d is equals to b square minus 4ac. b is minus 18, a is 4, c is 13, and putting the value here we'll get the two values of x, which is under root 29 plus 9 by 4 and minus under root 29 plus 9 by 4. Let's jump on to the next question. We have to find the irrational number between root 3 and root 4. So what we can do, we can write 3 as under root 9 and 4 as under root 16. So the irrational number between 3 and 4 will be same as the irrational number between under root 9 and 16. So the number between under root 16 and 9 will be under root 15, 14, under root 13, under 12, under 11 and under 10. So these are the number between 3 and 4, or we can say under root 16 or under 19. So these are the required irrational number between 3 and 4. Let's jump on to the next question. We have to represent the following point in xy plane and identify in which quadrant it lies. that is the first point is A 2 comma 3, B minus 2 comma 3, C minus 3 comma 5, D 3 comma minus 1. So here it is given the xy plane, or the, so what we can, we divide this plane in 4 quadrant. So it is like that: first quadrant, here it is; second, this quadrant; third quadrant; and fourth quadrant. So now we'll plot and see that which point belongs to which quadrant. So firstly, A 2 comma 3. So 2 comma 3, both coordinates are positive. For positive x coordinate, we'll go 2 unit toward the right hand side of the, there is positive side of the x. So here it is 2, and since the y coordinate is also positive, we'll go upward to the 3 units. So this point will be 2 comma 3, and it is in the first quadrant. After that, we have B minus 2 comma 3. It is in the second quadrant. So what we'll do, we will have, that is minus 2, that is the x coordinate is negative, so we'll go left hand side of the x axis to 2 units, 2 units here. After that, the y coordinate is positive, so we'll go upward, and this will represent minus 2 comma 3. It is in the second quadrant. It is clear. And we have after that minus 3 comma minus 5. So minus 3, the x coordinate is negative, we'll go 3 units in the negative side of x, and also here the y coordinate is also negative, so we'll go downward 5 units. So it will represent minus 3 comma minus 5, which is in the third quadrant. After that, we have D 3 comma minus 1. Here the x, that is x coordinate is positive, but the y is negative. So x coordinate is positive, we go toward the right hand side in x direction, we will get 3 units. After that, since y is negative, we will go downward minus 1. It is 3 minus 1, which is in the fourth quadrant. Let's jump on to the next question. We have to explain the Euclid fifth postulate by taking one example. So I will explain, I will read out the statement of Euclid fifth postulate. It says, if a line falling on a true straight line makes the interior angle on the same side less than 2 right angle, they produce indefinitely will mate on the side on which angle are less than 2 right angles. So what it says, that if we have two lines which are straight lines, and one of the other line intersect these two lines, the angle which the intersecting line makes with two straight line, if the sum of the interior angle, that is this angle we have, the sum of this angle and this angle is less than 2 right angle, that is less than 2 right angle means 180 degree, 2 into 90 degree, then if they produced, uh, after some time it will meet at a certain point, and the angle which they will make will be less than 2 right angle, that is the angle, that is this angle which they will make will be less than 180 degree. Now consider an example. We have, there exists a pair of straight lines that are everywhere equidistant. So there are the exist a pair of straight line which is equidistant from one another. Is this statement a direct result of Euclid's fifth postulate? Surely it is, because it states that the distance here, this distance is uniform throughout. No matter which point you take on these two lines, the distance between them will always be same. Uh, Keeping in mind that the point which will take will be in vertically downward. If I take this point, we have to measure the distance vertically upward. If we take point here, we have to measure the distance vertically downward. So if these lines have common distance, and they, since they make an angle, the sum of the angle, they make 90 degree, both make 90 degree to each other. So the sum of interior opposite angle will be 180 degree. So this proves that they will never meet because they are parallel lines. So it is their property that they will never meet. Hence, it is a result of Euclid's fifth postulate directly. Thank you so much.